Welcome to another session of Numeriscope Academy, a session that is going to be based on the discussion on the compound interest. If this is the first time you are joining, we have had other two sessions before this discussing on simple interest and how to calculate the simple interest using the normal method. And today it is an advancement from the previous videos. So if you have not watched the videos, you can make a visit to them and ensure that you have gotten a base on whatever we are discussing today, because this one is just an advancement of what we have covered in the previous sessions. So if this is the first time you are watching, I would request you to subscribe, you like, you share, and click on the notification button so that you are informed on the videos that we have recently uploaded and benefit from them. So today I want us to look at compound interest, how to calculate compound interest using the more normal way, as well as using the compound interest formula. Just to do a recap of what we have done in the previous videos, we have looked at simple interest, whereby we have the major terms used in simple interest, starting with the principal, we have the rate, and we have the time, and we have worked out examples that are going to reinforce the basics that you have on the simple interest. So today I want us to look at compound interest, how to calculate compound interest using the long method, as well as using the compound interest formula. So I'm just going to have an example that you're going to do practically and ensure that we have affirmed and have been able to work out this one without any difficulties. So to start with, I'm going to just give an example of a question, and then we do it practical on the board and see how and which are the steps that we follow in using in calculating simple that is compound interest. Now, for compound interest, unlike the simple interest you have realized that we do not have a change on the principal. Remember that the principal is the amount that you intend to invest, or the amount that you put in the investment business. Mostly you can have investing in fixed deposits, investing in money markets, again taking a loan. Whatever amount you take, it can also be referred to as principal. Then after that, there is that amount that you pay back. It is the so-called the amount. The amount is made up of the interest and the principal. So the interest that this amount is going to earn, or the additional amount that you add on the principal, or the amount that you have already taken, or maybe the money that you have already invested, whatever additional cash that is put on top of that amount is what we call the interest. Interest is always converted into percentage, and after it is converted as a percentage, it is multiplied by the principal amount, and also multiplied by the period of time that you have for the the investment period, or the payback period. Now, let me just do a recap on simple interest just a little bit, so that at least we can set a pace on the compound interest. Assuming that Job took a loan from a bank amounting to Kenya shillings 70,000. That is to be paid back at an interest rate of 16% per annum. Remember, there is an information that you need to be very keen about. Anytime you are given the interest rate, it is always important to note whether it has been given per month or per year. If it has been given per year, then the period that you are going to work with should be in years. If the interest rate is given per month, then the period that you're going to pay back, or the period that the interest is going to be earned, should be in months. Do not make a mistake to work with years and months at the same time. If it is years, it should be the years in the interest rate, and also the years should also apply on the period that you're going to be given. So now the question is, how much money did Job pay back after 2 years? This is just a recap of what we did in the previous videos, so that at least we can set a pace to compound interest. We said that simple interest is equals to principal times rate times time, all over 100. And this is going to give us, I'm just rushing because we have already done this, so it is going to be 70,000, which is the principal, multiplied by the rate, which is 16%, then multiplied by the period, which is 2 years. So multiply by 2. Then from there we can simplify, getting this is going to be 2 zeros cancels with 2 zeros, but we can have 700 times 16 times 2. So this is simply 700 multiply by 32. So you get 22,400. 22,400. So that is the interest that is going to be earned after 2 years. Now being the interest alone, remember that this question can also be posted asking for the amount. Remember that we said that amount is equals to principal plus the interest. And now the principal amount that we have here is already 70,000. So it is 70,000. You add the interest, which is 22,400, and this is going to give us 70. That is 70,000 plus 2,000. We get 92,400 shillings. Now remember that these are two different questions, whereby this one is only asking, it is only giving us the interest, and this one is giving us the amount. We said the amount, it is a total of the principal plus the interest. Now it is important that you note that these ones we have worked with per annum as well as in years. If this one you've been told that the interest is to be earned after 18 months, this is going to be now a different case. It's going to be a different case because when you're working out this question, you'll be required to apply the rule of working with the same units of measure. In this case, we are dealing with months and we are dealing with interest per annum. It is either you change this 16% per annum, you make it to be per month, or else you convert 18 months into years. 18 months, I take that we change this one into years, which is 18 divided by 12, which is going to be 18 divided by 12, which is going to be 1 and 6 over 12 years, which is equivalent to 1.5 years. So that now when you are working out this question using this formula, it is going to be 70,000 multiplied by the rate, which is 16% per annum, then multiplied by 1.5 years. So multiplied by 3/2. So because 1.5 converted as an improper fraction, you are going to get it is going to be 3/2. And then from there you simplify by 2, 1. You divide here by 2, you get 8. Then 2 zeros here, you go with 2 zeros. So it is going to be 700 multiplied by 24 to get, you're going to get, which is going to be 00861. So you're going to get that the interest is going to be 16,800. So this one is going to give us an interest of 16,800. Now you have to get the principal, that is the amount. You're going to take the principal and then you add the interest that you have already earned. So this one is about a recap on simple interest. And very fast we are going to rush and look at the compound interest and how it is calculated. We are going to start with a step-by-step method or the long method, and then thereafter we are going to look at the compound interest formula. So using the same example, I'm not going to do away with the figures, but what I'm going to change first, I'm going to change the duration, and I'm going to say that this one is going to be 3 years. 3 years. And then this one is not going to be simple interest, it is going to be compound interest. Now we use the same formula. The formula does not change at all, but what you're going to do, you're going to ensure that for the compound interest it is somehow different from the simple interest, because you'll be required to work out the simple interest, that is the compound interest is going to be worked out every year. You are not going to work out the way we have multiplied the period or the time. We are not going to multiply by the exact number of years. Instead, you are going to work out this question every year. You have realized that when you're dealing with a simple interest, the principle does not change. It is going to be to remain constant from the start to the end. From the start to the end. But for the compound interest, after every year, the principle is going to change. How is it going to change? It is going to change because you are going to have the initial principle and the final interest for the first year. It is going to be put on top of, or it is going to be added to the principle that was there initially. For example, in my pocket I have 100 shillings. If I have 100 shillings, maybe after a certain period of time, let's say after a day, I add a 50 shillings note. So in my pocket, I'm going to have the 100 shillings that I had initially, now plus the 50 shillings that I've added, assuming that the 100 shillings was the principal and the 50 shillings is going to be the interest. Therefore, in my pocket, if I'm going to add anything else in in that pocket, it is going to be added from the 100 plus 50 that I already have. So the principal changes because the interest is going to be added in the original amount that I had uh, as I was starting to invest. Or maybe it is going to be an additional amount that is going to be inclusive of the principal plus the interest. That is how the compound interest is going to be different from the simple interest. So practically, let's work out this question. You've been told that Job took a loan from a bank amounting to 70,000 shillings that is to be paid at an interest rate of 16%. How much money did a Job pay back after 3 years? So we are going to say this one is now it is now going to be compounding. So when I put that one there, being compounded means it is going to be added. So it is going to keep on accumulating. So using the same formula, principal is equals to, that is interest is equals to principal times rate times time all over 100. We are going to take 70,000, we multiply by the rate which is 16%, but you are going to do this one every year. So you're not going to multiply by 3 years, you're going to multiply by 1 year. So we are going to talk about the first year. The first year, we are going to have 70,000 multiplied by 16% multiply by 1 year. So we are going to have the first year is going to be calculated that way. Then the second year, we cannot go to the second year having not calculated the first year, because the principal for the second year is going to depend on the amount that you're going to get in the first year. So in this case, we are going to have this one as multiply this one, you're going to simplify this one by 2 zeros by 2 zeros, which is going to be 16 multiplied by 7, which is going to be 112 and 2 zeros. So it is going to be an interest of 11,200. That is purely the interest. But now for about the amount. Remember that amount is equals to principal plus the interest. So by the end of the first year, this one is going to be having 70,000, which was the initial amount, the initial investment or the initial loan, plus 11,200. So this one is going to give us 81,200 shillings. Now, 81,200 shillings is what is going to be in the bank by the end of the first year or by the start of the second year. Note that there are those terms that the examiners may use to confuse you. By the end of the first year or by the beginning of the second year. So by the time you are investing that amount in the second year, my account will no longer be having 70,000. It will be having 81,200, which is going to be it is going to be a total of the principal amount that I had initially plus the interest it has gained by the end of that year. Now, my second year's principal is going to be the amount by the end of the first year, which is going to be 81,200 is going to be my new principal times the same rate, which is 16%, you multiply by the second year. So it is going to be worked out like that. The principal will change, and if it changes, it means that the interest will also change. It will also increase. Now, we simplify this. You have 2 zeros here. We have 2 zeros here. So it is going to be 812. You multiply by 16. 812 multiplied by 16 to get you get to 9 912. So we are going to have a total of 12,992. So for 12,992, this is simply the interest for the second year. Interest alone. Now you'll have to go for the amount, because the amount is going to be now the principal for the third year. So by the end of the second year, we have earned an interest of 12,992. So for you to get now the total amount, remember that amount is equals to principal plus the interest, which is going to be 81,200. You add the interest for the second year, which is 12,992, which is going to give us 29149. So we are going to have a total of 94,192 shillings. So that is simply going to be the total amount in the bank by the end of the second year. Remember that this one is now going to be the principal for the third year. So the principal for the third year is going to be, so we go to the third year. For the third year is equals to principal, which is now this amount, 94,192 multiplied by 16% multiplied by the third year. So you can see I have the first year 1 1 1. So it is the first year, the second year, and the third year. So in this case, now from there you can simplify. This one cannot be simplified, so you just need to multiply 94,192. You multiply by 16. This one you divide by 100. So you can take your calculator. So when you take your calculator, you are multiplying 94,192. 94,192. So 94,192 you multiply by 16, then you divide by 100. So the interest for the third year is equals to 15,071, rounded off to to the nearest whole number. So it's 15,071 shillings. So this is simply the principal. But what about that is the interest? What about now the amount? Remember that the amount is equals to principal, the principal plus the interest. Remember that my principal was 94,192. You add the interest, which is 15,071. So you can put that one together and see. So 94,192. You add 15,071. So this one is giving me giving me a total of 109,263. 109,263 shillings. So that is now the total amount that is going to be in the bank at the end of the third year. Remember that this question can be tested using asking for various parts. It can be divided into different parts. The first part can be asking about the interest for the 3 years. If it is asking the interest for the 3 years, you take 11,200, which is the interest for the first year. You add 12,992, which is the interest for the second year, and you take 15,071, which is the interest for the third year, and then you put them together. What if the question is also asking about how much money did he have in the bank by the end of the third year, which is going to be simply now the total amount, which is simply the initial amount, which is 70,000 plus the interest that you have already answered. So that is simply how we use the long method to calculate this question. And There is a simpler method to work out this one using the compound interest formula. So this is just an introduction so that you understand how compound interest works and how you are supposed to handle any question that is brought. Now, the reason as to why we use the compound interest formula, it is because you do not expect to work out this one just the way you are working out every year. If you are told to work out in 10 years, maybe you have been told that what is the compound interest after 10 years. You may not be in a position to work out, or else it is going to waste a lot of time working out all these. Now, we have a simpler method to work out this question using the compound interest formula. Let me just show you how to work it out using the compound interest formula. So the compound interest formula, it is very simple, but provided you must be in a position to understand each and every part of it. So the compound interest formula, the compound interest formula is equals to, so this one is the compound interest formula. It is amount. It is always going to give you the amount. That is very important to note, that it is going to give you the total amount. If you are to calculate the interest, it is going to come from the amount that you're going to calculate. So the total amount is equals to the principal, which is the initial investment or maybe the loan that you take, into brackets 1 plus r all over n into brackets nt. So which is amount is equals to principal into brackets 1 plus r over n, then mod power nt. N, where a, let's start with a is the amount, where a is the amount, then p is the principal, then r is equals to the rate, and n is equals to the number of times being compounded, number of times being compounded, and then t, because we already have n here and it is already explained here, so it is not going to be different from that. And then from there t is the time or the period. Now let's put that formula into practice. And then we see whether we are going to land at this final answer that we have there. Now we have the principal, so we have the amount is equals to the principal. We already had the principal somewhere. See, so here it is 70,000, then multiply, so it should be in brackets like that. So 1 plus rate is 16%, so it is 16% all over n into brackets nt, n multiplied by t. Time is 3 years. Now I want to explain something here. When you're talking about n, it is the number of times it is being compounded. So what do I mean by that? In 1 year, how many times has this 16% been subdivided? Is it going to be compounded for the whole year? Is it being compounded half a year? Or is it being compounded quarterly? Is it being compounded monthly? Is it being compounded daily? So those are the various issues that you need to confirm when you get such a question that is talking about being compounded differently. So in this case, the 16%, if you look at my my question here, the 16% is per annum. So if it is per annum, it simply means that it is being compounded once in the whole year. So in this case, my n is going to be 1 because 16% per annum simply means it is 16% for the whole year. It is going to be for the whole year. So this n is going to be replaced by 1. And here again, it is going to be 1. So from there, we can go ahead. Now, something else that I would like to explain, when I talk of R, R is the rate. Now, using our case here, we have 16%. 16% is the same as 16 all over 100, and it is the same as this one, 16 over 100 converted into a decimal. It is going to be 0.16. So you'll be using 0.16, or you'll be using that fraction converted into a decimal. So it is going to be 70,000. You multiply into brackets, we have 1 plus 16% divided by 1. It is simply going to be 16%. So it is going to be 0.16. So plus 0.16 into bracket cubed, or power 3. Then from there, you can work this one out. It is going to be 70,000. You multiply by 1.16, because 1 plus 0.16 is 1.16 cubed. So this one is going to be 70,000 multiplied by 1.16 cubed, 1.16 power 3 is giving me 1.5609, 1.5609 rounded off to 4 decimal places. And then when you multiply these, so multiply by 70,000, so 1.5609 multiplied by 70,000, it is giving me 109,263 shillings. So that one gives us now the final amount. Remember that this one is the amount. It is going to be the amount. So it is giving me 109,263. If you look at the final answer that we had here, which is 109,263, is the same answer that we have landed, we have gotten after calculating now using the compound interest formula. So that is simply a simpler method as compared to what we had done here. You can also look at the space that we have used. The space that we have used here, it is not as big as the ones that we had worked from here up to down here. So this one is going to be simpler. Again, it is going to be to save your time, and again, it is also going to save the space that you are going to have. Now, before I conclude on on compound interest, let me now calculate a question that is going to talk about if it is going to be compounded maybe quarterly. We can use that. You can use that example, being compounded quarterly. So 16%, 16%. Let me change it to 8%. At the rate of 8% compounded quarterly. Compounded quarterly. So if it is compounded quarterly, Remember, when you talk of quarterly, it simply means that it is a quarter of a year. A quarter of a year is going to be a quarter of 12. A quarter of 12 is going to be by 4, 1 by 4, 3. So it is after every 3 months. So how many 3 months are we going to have in a year? We are going to have the first 3 months, that is from January to March. That is the first part. Then March, April to May, to June. That is the second part, the second quarter. Then we can talk of July to September. That is another quarter, and then from there we can talk of October to the last month, which is December. So we are going to have those 4 quarters. Those 4 quarters are the ones that we are talking about being compounded quarterly. Now, using the formula, we are going to have to use the same values to calculate this question that we have now changed the interest rate. It is now being compounded quarterly. Therefore, we are going to say that amount is equals to principal into brackets 1 plus r over n into brackets nt into brackets nt. So from there, we replace these letters with the corresponding values. So we are going to have the principal here is equals to 70,000 once again. So 70,000 into brackets 1 plus. Remember that we said that 8%, we are going to work it out in decimal form. So 8% is going to be 0.08 compounded quarterly. So the number of times it is being compounded, we have been told it is compounded quarterly. Therefore, it is going to be compounded 4 times the whole of that year. Therefore, we are going to divide this one by 4. Divided by 4. And then from there, you multiply by n, which is 4, times t, the number of years are 3. So from there, we work out 70,000. You multiply by 1.08. We can as well divide 0.008 by 4, which is going to be 0.02. So it is 1.02. Then compounded, if it is compounded, it has a power here because it is being compounded 4 times, then 3 years. So power 12, because 4 times 3 is going to be 12. So we calculate that 1.02 power 12. This one is going to give me 70,000. You multiply by 1.2682. So this one is going to give us, it is 1.2682. You multiply by 70,000. This one is going to give me 88,774 shillings. So this is simply the total amount of money that is going to be in the bank at the end of the third year. Now remember, this one is the amount. As we said earlier, this one is going to give you, the formula is always going to give you the amount. If it is about the interest, we said that amount is equals to principal, the principal plus interest. And now the amount is 88,774 is equals to principal, which is 70,000. Now plus the interest that you do not know how much interest is there. Now from there, you want to be left with interest on one side. So this one will require you that you leave this interest on this side, and then you take this one to this side. Remember that when it crosses this sign, it is going to change the sign from positive to negative. So it is going to be 88,774, you subtract 70,000, and this is what is going to give you the interest. Then from there, this one is going to give me that the interest is 18,774. It's going to be the interest of the period. So it is the interest that is going to be earned after 3 years. So this is simply how you calculate compound interest using the formula, the compound interest formula, which is principal into brackets 1 plus r over n into brackets power nt. Remember that n is the number of times it is being compounded, then t is the number of years or the period, and then r is equals to the interest rate, and then p is the principal, and a is the amount. Now, I'm hoping that this video has been useful. You have benefited from this because you just need to look at that you just need to understand the concept and the unknowns, or the letters, what each and every letter stand for. So with that, guys, I'm hoping that you have benefited from this. Remember to subscribe to this channel, Numeriscope Academy. Click on the notification button, share this with your friends so that they may benefit as well, and again, like the video if you find it useful. Till we meet next time, it is a goodbye for now. Till we'll meet next time, so that we go to the other step. Thank you and enjoy your time.